Welcome to the lesson with Dr. Pal. Let's take a look at an example of um, using integration or differentiation of series in order to find a power series representation of a function. For instance, what if we had a natural log of 1 plus x? Okay, now what happens if we take the derivative of this? Take the derivative and we end up getting 1 over x plus 1. Now, let's rewrite this as a series. Okay, we could think of this as, okay, maybe I'll rewrite this as 1 plus x. And we could think of this as 1 over 1 minus negative x. So it's the result of a geometric sum formula, which looks like this. 0 to infinity with a negative x to the n, which we could rewrite as negative 1 to the n x to the n. Okay, so we take a derivative and we end up getting this. So how do we get this? Well, we just go backwards. We just take an antiderivative. And we can do that term by term. So we end up getting negative 1 to the n x to the n plus 1 all over n plus 1. Now notice this n stayed the same here because it was associated with the negative 1, which is a constant. Really, it was just this x to the n that had an antiderivative here. X is the only variable. Everything else is constant. Okay. And so we do that. We have n equals 0 to infinity, but realize that we have to take this whole series and add some value of c to it. Now, as we look at this, we're adding a value of c to this. We know then that will be equal to the original because we know they have the same, this is the same derivative as natural log of 1 plus x, just off by a constant c. So, well, why don't we just plug in a value of x? In fact, why don't we plug the center of this series, so 0, in right here, and make all, and so notice what happens. The smallest power that we have is when n is 0, which is 1. So really plugging in 0 for x makes that whole guy 0 on that side. At x equals 0, we're going to have 0 plus c is equal to the natural log of 1 plus 0. Natural log of 1 is just 0. So 0 is equal to c, which means c is 0, meaning that this actually is, as long as we're in its interval of convergence in the domain of this power series, where this is well defined and converges, these are equal. So these are equal in the interval of convergence. Thanks for watching.